background. It's going to help us to have a better webinars from going forward. So let me look at those polls and then launch it. Okay, so let's start this one. Okay, so while you are having, if you don't mind to fill out the forms, okay, you guys hear me now? Okay, okay, audio background because I wasn't talking. So please fill out our surveys, and I will while I am making an introduction. So hello everyone, welcome to today's event where we are going to address some interview practices and interview questions on the space, and we're hoping that it's going to help you. And we have here Magnimind team and more our mentors and instruction mentors and lecturers here, like our faculty here, Dr. Jeran, Semi. We are going to have this webinar with you. So Magnimind has been founded a while back, almost 10 years, focusing on data science and AI education, and founded by Stanford, majority of Stanford actually, scientists to address the needs in AI and data science education. In general, we focus on it. We focus on a lot of fields in data science. We also specialize in it. And we have meetups. We have 7 meetup groups with 30,000 members. If you're not a member of any of those meetups groups, we recommend to sign up all this, especially the first one. If you're going to sign up one, you can sign up the first meetup group that's based in Silicon Valley, Bay Area. And we have YouTube channels, social media platforms. Highly recommend to sign up in LinkedIn, YouTube, so you can get a direct information about our programs. And we are almost starting a new program, mentorship, data science internship program. So we had this program for a while, but we upgraded this time. We give actually different tiers of this program, different layers for beginners, intermediate, advanced. Earlier, we were not able to accept the student who are beginner. So now we can accommodate beginners and intermediate people to have a better program. So what we provide here, several mentors, 4 to 5 mentors, work with students on real life projects. And then they also work on to prepare interviews, to get the interviews, to pass the interviews. And our focus has been shifted to more landing jobs in FANG companies. And that standard we are building our programs. So we upgraded our programs. Our batches starting in next week or so. It's a 101 personalized training with internship and data science experience. You can click the last link that our team has shared to get the details and packages. If you need more information, you can send us an email at info@magnimindacademy.com. And I will start to introduce our team here. Myself, I'm a Stanford scientist and a serial entrepreneur, focused on AI and data science and working a lot of medical AI projects, and both in industry and academics. And Dr. Jeran, faculty in San Jose State University and then co-founder of Magnimind Academy. And then he's been also in several other universities, Santa Clara University, Kai's University. He's been building AI models in medicine, marketing, and other fields. And Semi Hasaj, he's a MIT alumni and working on C3 AI. And he's been hiring a lot of people in this field, data analysts, data scientists. He's developing different data science models, including LLMs. So our team, both from academics and industry, is going to give you insights, and hopefully you're going to get the most out of from this program. If you have any questions, you can actually list those in Q&A sessions of this webinar, so it will be easy to track it. So when Sami and Dr. Jaran is ready, you guys can start.
Cool. All right. Thank you, Murat. I'm happy to jump into it and just share some of the material we're going to go through. So let me just share screen right now. Okay, cool. Hide this out of the way. Okay, perfect. So yeah, like Murat was saying, currently a data scientist at C3 AI, working a lot on like LLMs and Gen AI and agents and all that good stuff these days. So if you have any questions, feel free to just drop them in the chat. I'm also, again, we hire at C3, you know, I'm conduct interviews, so at least I feel like I know on the ground level what companies might be looking for in interviews. We do resume reviews as well. I'm involved in that as well. So hopefully I can just help give some tips. Dr. Jarad as well has a ton of experience here, so we'll try and help out. For this workshop, we have mostly just a lot of practical questions you might see in a data science, data analytics interview. But first, I wanted to just preface like what we're going to cover, maybe some of the things that come before the interview, which is a lot of the times I'm finding as important, if not more important than the interview itself, and hopefully some tips. So let's jump into it. Yeah, biggest goal is just hopefully giving everyone a plan and an understanding of what to expect for the interviews that you may have. And just to kind of highlight what this path might look like, here's 8 hypothetical steps. Maybe I can make this, can start presenting, make it a bit more full screen. Okay. Obviously, starting with the resume and job hunt, typically you might have some type of online assessment, like a take-home, recruiter involvement and phone screens where they're just trying to sniff out your motives. Some usually 1 hour technical screen covering various different technical topics. There might be a take-home assignment. There will surely be some type of virtual on-site, which is several interviews of potentially several hours diving into different pillars that a data science job is looking for. And then, you know, the best part, if and when you get the offer, we can also think about negotiating that too. So again, we're going to cover a lot of actually practical questions on ML, SQL, and whatnot. I'm just going to flash them here. I don't want to go through them right now, just giving you a flavor of what might come up. Okay. Point is, as you can tell, it covers a lot of breadth and even a fair amount of depth. And it definitely does feel like the interviews are getting more, the bars being raised, which I think is fair. I literally just went online and tried to find people's opinion on this. And yeah, that seems to be like a common opinion, you know, months of daily practice across coding, algorithms, knowledge, and so on. So that's really, just wanted to preface what might go into the interview. we have this 60-minute workshop, and I'm really hopeful, and I just love to and give tips and try to help people prepare. Really, the interview itself is like its own SAT type of thing. You have to prepare for it in a certain way. So that's what we're trying to do here with this workshop with Magnimind, and just help as best that we can. Really, it's to in the 60-minute interview again, like show this path uh, from point A to point B, B being getting the offer. So we'll cover these topics again, like I talked about, from resume tips, the actual job hunting, a lot of technical deep dive into various questions. And yeah, we have 21 technical questions that I'm sure we won't cover, but I'd like to make it interactive. So maybe 5 minutes, 10 minutes before we get here, and then interactive Q&A. We can give you a flavor of what a question might look like and what a good response might look like, and go from there. So what I'm finding these days a lot, and just keeping up with forums, is even getting the interview is quite a challenge, and I definitely recognize that. There's a lot of things that go into getting the interview. First, and think about it, all this interview prep is great, but if you're not even getting the interview, which I'm finding is the case for a lot of people, then that's the first great filter. So we need to address that first and foremost. There's a few different pillars to focus on. One is just resume. There's a lot of tips out there, but honestly, for formatting, find what like Harvard, MIT, Stanford, these top universities basically just show their format. It's very standard. When I talk to recruiters, they really just want to scan the resume in 10 seconds, know how to read it. So the format needs to be familiar and easy to read. You don't want like generally a crazy unique resume because they don't know how to scan it. And it needs to be clear that this resume is like tailor-made for the role they're looking for. It may not be fair, but the resume really should look like it's tailor-made for the job. The keywords, the experiences, the job titles. I even made this mistake before where it's like, oh, well, someone reading this should be able to make the connection that I did B and B is related to A, and this job is A, therefore I'm qualified. But it's a false assumption. It's just imagine that the most simple search is a hard keyword search. That's what the resume needs to convey. So hopefully that's one practical tip that can help. All right, and even on our end, like we get many, many resumes. The reason it's like this is that you get many, many resumes, all of which are pretty qualified people. So you really have to, unfortunately, be very picky to find the most qualified seeming resumes and then advance those. That's kind of just the state of the market. And then some tips for actually writing the bullet points. Probably the biggest pitfall here is just writing a job description. Try to not write a job description or a list of tasks. Really try to highlight your impact and things you've accomplished that will make someone go, oh, wow, that's interesting, and follow up from that. For applying, just know that this can take months. I think what I've learned, even myself, just kind of keeping up with this, if you're using online applications, first of all, if you have a referral or a strong connection, that's probably your best bet. But if you don't, these job applications, that the ones you'll see on like LinkedIn and other job boards, think of it like a queue. It's first in, first out. And typically that queue gets filled up extremely fast. So within 24 hours, there's already, in most job positions, hundreds of candidates already there. And again, just from talking to recruiters, at that point, they already have so many applicants. The job search is done, like within 24 hours. They have enough candidates to move forward with. So my practical tip here is you have to be on top of actually finding fresh, very new postings. Otherwise, you're just too far behind in the queue and your resume never even gets considered because there's too many people in front of you. So again, hopefully it helps. And yeah, just some other tips. Even then, response rates will be low. Try to tailor it to the job. That's always helpful. And if you're looking for referrals, feel free to message people and be straightforward. Just, hey, I'm looking for XYZ. And sometimes people will help, sometimes not. But if you shoot enough shots, it'll work out in your favor.
Yes, Semi, may I add just one thing? So this
Mhm.
may be an anecdotal evidence. It's not, I cannot generalize this, but for referrals, someone definitely is going to help someone from, say, one of those big companies referring you. So they have their own actually system of accepting the referrals. But on one layer on top of that is if the person referring you is someone, say, from the one of the data science teams and can forward your resume directly to the recruiter, most likely you're gonna get a response the same day or in a couple of days. Yeah.
Yeah, exactly. And recruiter and also hiring manager. If you can get the resume directly to the hiring manager and skip the HR recruiter filter, that's also an easy way to one day like move forward, because they can just manually review it. Cool. Okay, so hopefully that helps with like the first maybe great filter of going from nothing to landing some interviews, right? Mostly focusing on how to apply and your resume to apply with. Next is, okay, you have some interviews now. That's great. What to prepare in. And the reality is there's a lot of breadth in what can be covered. Like technically, just pure coding languages. It could be SQL, it could be Python, different hands-on modeling and data explorations with like pandas and sklearn, your machine learning and statistics knowledge, right? Probability knowledge, just core concepts. And then also for sure, what's very common is some type of, I'll just call it problem solving case study. Oops. Whether it's machine learning or A/B testing or analytics or product sense, there will be generally at least one, maybe two of these type of problem solving cases. But again, there are templates to follow and help you out here, which hopefully we'll kind of address. Maybe before I go forward, I'll just take a quick peek at the chat in case there's any questions.
Let me when you are looking at, let me add one thing.
Over.
So let's say you get a technical phone screening interview, and then the recruiter sent you an email giving you some tips on what kind of questions will be asked. Please do not take it as is. So make sure that you clarify. Don't be shy to send email to recruiter, ask more questions about what kind of questions you can expect in that technical interview, because there are so many different, there might be many different jobs appearing as data scientists depending on the needs of the team, right? So the job description may change, and recruiter may be sending a very generalized email, which is not giving you full picture of what kind of questions. Maybe some specific type of questions will be asked in the technical interview because that team is looking for someone with those skill sets. So make sure that you ask clarifying questions to the recruiter to understand which questions, what type of questions, what kind of questions, not which questions you might expect in the technical interview.
Yeah, that's a fantastic tip. Best thing you can do is at least roughly understand the framework that they're going to ask you in the interview. Another tip there too, actually, I just got reminded, is check out Glassdoor or other forums. What do people typically say are these interviews like? Again, it just helps you be more tailored into your preparation. So also, the word data scientist these days is a gigantic umbrella term. And I think the industry is starting to segment this and give things different names. Since two people who are called data scientists can seemingly have completely different job responsibilities and functions in day-to-days. So understand when you're applying to any position, what kind of flavor of data science this is. And really, in one simplified spectrum, if I just wanted to have one dimension, on the left, it's more like a product, you're more in product analytics. If you look at Meta and you look at their data science position, they call it data science analytics. And it covers more this type of material, from SQL, A/B testing, hypothesis testing, your statistics knowledge, and just generally like good, let's say, stakeholder communication. Really, your function here is to turn insights from data into actionable recommendations. So you're kind of the middleman between technical concepts and business people, which is a super interesting type of role to be in. But they are looking for people who can do the technical things that are outlined here and also explain those things to non-technical members, business people, and just have a business impact. On the other side is something that is basically more like a software engineer, but with machine learning specialization. So again, if you, let's say, look at Meta, they actually call the machine learning engineer a software engineer, comma, machine learning. Because the concepts are very, very similar. They will expect you to have very strong coding skills, let's say Python, and the interviews will reflect this. Maybe some light SQL, but also very strong understanding of machine learning, both conceptually and practically, which they'll try to expose and companies will try to expose via case studies. Walk me through an end-to-end machine learning problem. And, they'll try to, at that point, you want to have a framework of how to go from A to Z, while also potentially going into sufficient detail on certain concepts when needed. So just be aware, these are the two main flavors. There are more than this, but you want to cater your resume and your interview prep according to at least these two different sides of the spectrum. I won't go too much into detail here, but there are some great resources to prepare for this. These slides are being recorded. I think they're being published to YouTube, so you'll be able to reference the content here again. But I've just aggregated, and we've aggregated some helpful resources for all of these different categories: ML, Python, SQL, A/B testing, general. So hopefully these help.
Yeah, one thing, Semi, so these are really great sources. So I went through almost all of them in detail. Couple of things. Actually, in the interviews, you may be receiving similar questions or same questions that were asked before, and then they are already posted in these resources. You can find many different resources from Reddit, people who took interviews before from Glassdoor, that are posting the questions that they received in interviews. I just have two comments on that. One is, please keep in mind the person who's making the interview, asking the question to you, may ask the same question in a different wording, and sometimes may not be giving the full question, but actually you already solved that question before, but you may not understand that he's asking that question. So again, anecdotal evidence. So I'm telling you this with anecdotal evidence. Second thing is the interviewer may have a very one version of the answer in their mind, and then they want you to give that answer. So please just keep this in mind when you're looking at these resources and then see that, oh, I know the answer to this question, so I can answer this question in the interview. Try to look at the question from different angles. Do not take it as is. So just keep in mind that the other person who's going to ask the question may be asking it in a different way.
Yeah, fantastic advice. And again, it also makes me remember. Definitely don't maybe interview the interviewer is the wrong phrasing, but I think one of the biggest error modes candidates make in the interview is just, it's kind of like an LLM. You get a prompt and you just start spouting thousands of tokens. Do not do that. make sure you clarify exactly what the interviewer is asking. They actually oftentimes want you to clarify because they want to see part of data science is taking an ambiguous requirement and actually making a solid plan and step out of it. Ask the interviewer for clarifying questions. Clarify your assumptions. Tell them what you're going to do before you go into do it. Because I often find, yeah, a candidate, and nerves get the best of us sometimes too, and it can just happen. But definitely a wrong approach is to just jump into solutioning before you've sufficiently clarified the questions. I've personally messed up many interviews, especially when I was less experienced doing this. I get a vague question and I just start rattling off. And then the problem is, as an interviewer, it's like, well, I don't want to intervene too much. So yeah, it just becomes messy. Another anecdotal one, I've had an interview question where it's like some director in the company heard your metric went down by 10%. What do you do? And my first approach was to start, oh, well, let's double check our metric. Let's do this analysis. We can split the data by XYZ. And then 30 seconds into the question, I realized I was jumping into the solution. And I thought, wait. Might be going too much into detail here. And I asked my interviewer some clarifying questions. And basically all they actually wanted to check was that you would ask the right clarifying questions, because their approach was like, well, shouldn't you figure out how the director heard this number? That's really the right answer before you jump into a day or 2 days of analysis. Figure out where they got this information, and even if it's accurate information. So keep this type of content in mind. Cool. Okay, so there's some content here on just kind of the, I guess, scoping when you may feel ready. I think I just want to jump into the QA part, so I'll just quickly parse through this. And we'll get into, okay, I think we already covered a lot of these general tips. And yeah, hopefully this kind of at least illuminates the path a bit better, a little bit more prepared of what to expect. But okay, let's jump into some actual mock interview questions now. We have different categories, right, across all these different technical pillars. Maybe we can do 1 or 2 across each one. And the name of the game here is interactiveness. So write your responses in the chat. We can review them, kind of aggregate the answers, and then explain the thought process behind everything. So maybe a good first question, it's a gold standard question in ML, is explain the bias variance trade-off and some ways you would deal with it. Okay, so let's pretend you're in the interview right now. And again, feel free to write the responses in the chat. We can try and review them. Maybe one first approach would be to discuss what is bias, what is variance in the context of machine learning, of statistical modeling.
So as maybe participants are writing their answers, or the audience is writing the answers. So a couple of things. This is one of the very classic question you may receive in a data science interview. So it may be an opening question. So please keep in mind, you may know the answer or you have a good idea about the answer, but whatever you say when you are answering, the words that you are choosing, the way you are answering this question may bring up some other questions. So make sure that when you say answer the question, make sure that you know the terms that you are using, because a follow-up question may be built on what you are saying.
Yeah, exactly. One thing I remembered, not exactly related to this question, but it's the use of AI in interviews. I think two thoughts here. One, I think the industry will have to adapt to this, and I'm not sure how that'll look like, but it'll have to happen. B, just don't bother. I think interviewers know it's quite apparent, and any like competent interviewer will be able to ask sufficient answers to detect it. Just don't bother. It's very obvious when candidates are using AI in interviews. Um, Best thing you can do is just try to be transparent. If you're like taking notes, that's fine. But also keep in mind, like there are risks, right? I mean, there are cases if you are caught, you might just be blacklisted from that company and not be able to ever apply again. So just make sure it's tempting, but it's really not worth it. And okay, I'm seeing some responses in the chat. I think they're going along the right path. I actually really like this question because you can go very deep into it. Like Dr. Chavan was saying, you can ask follow-ups because there's like a textbook definition that you might read again from your textbook or from like a blog or ChatGPT. But then I'm trying to understand like how deeply does the candidate really understand these terms intuitively? So I'm seeing indicates the spread of your data. Okay. So maybe one thing I can cover, and I'll just minimize the chat. You know, this plot is basically classic. Bias and variance are just two different errors from your model. And generally, as you train, as you develop your model, you're trying to find this global minima where bias is sufficiently minimized and variance is sufficiently minimized. Generally, when we think about these terms, right, total model error, right, there's a trade-off here between the ability of the model to fit the training data and its ability to generalize to new data. A nice way to think about bias is you're making overly simplified assumptions of the underlying nature of your data. Like linear regression is a great example here. You're assuming there's actually linear relationships across your data relating to the dependent variable, which is often not the case, right? So that's why you may get high bias error from a overly simplified model. The flip side is you can make your model more complex. Think of like a super deep and super wide neural network as the end of complexity. But what that then means is your model is trying to find every bit of variation, every bit of just difference in your data. And a lot of the times it's fitting to noise, which makes it fail to generalize. So you also don't want to fit to noise. You want to try and find the underlying signal without going too complex. And that's the trade-off we're talking about. I think some people mentioned in the chat, like normalization of data. That's a great technique. These are generally, you can think of them as regularization, which is to not let your model get too complex beyond a certain point. That's how I like to think about it. Other things like cross-validation using ensemble models, they can help minimize variance while still keeping a sufficiently complex model. So again, interviewer can go like 80 different directions here, but it's always fun to see people's, I like the intuitive understanding of bias and variance.
Yeah, by the way, we received some great responses. Maybe not everybody is seeing, so they sent to host and panelists in the chat page. Julie, Mark, Mariam, and Mar. They sent really good responses. Actually, responses looking at question from different angles.
Yeah, good point. Actually, those are great responses. Feel free to, I mean, if you'd like to just respond to hosts and panelists, that's totally fine. If you'd like to share the responses with everyone, that's great too. It's actually just one of the drop downs available in the Zoom chat. So whatever everyone is comfortable with. Okay, this is also kind of like a classic, but it's funny because I still find even when data scientists know this is the case, it still is a bias in our mind that we like big numbers that are close to 100%. So let's say this, so, a stakeholder tells you, or somebody tells you their existing model has excellent performance because it has 95% accuracy. Walk me through, why might that assessment be misleading? What would you want to check before you say, hey, that's a great model, 95% accuracy, that's a beautiful number, let's ship it? Okay. I'm liking the responses pouring in. This is great. This could also be a question where you could easily ask follow-ups, and the follow-ups would show your understanding of their question, which is why this might be misleading.
Yeah, I may even ask some questions on different metrics. So what kind of other metrics you would use if you think accuracy high is misleading?
Exactly. Yep, and I'm seeing some of these metrics being brought up in the chat. It's awesome. Some great answers. I see Julie's great answer. Okay, I think I'm seeing like two common themes, which are both correct. And you might want to clarify. One I saw in the beginning is overfitting. Oh, okay. I mean, are we just overfitting? Is this also just being reported on the train set and the model has completely overfit to it? Good clarifying question. Let's assume we're not overfitting. Let's assume this is test set performance. And the developer of the model, let's just pretend that they haven't done any data leakage or anything like that. But that's a good sniff test. You should always question whether there was any data leakage or overfitting. Those are like the two most common causes of incorrect model performance, right? What you say it performs as is not reality. And then Dr. Duran brought up the second point of that, which is maybe different metrics. And there were some other really great answers in the chat talking about this other case. Well, what is accuracy, right? The problem with accuracy is it's just how many predictions did you get right? The problem is if I have a very imbalanced data set, accuracy is a trivial metric. For example, let's say it's fraud, which I think Julie brought up in the chat, or spam detection. 95% of instances of examples are not fraud. So what's a very easy way to get, let's say, 99% accuracy? If 99% of our data is of one label, I predict a model, it always predicts that label, right? And then boom, I have 99% accuracy or 95% accuracy. But of course, it's not a very useful model. So then we'd really want, what you might want to get into is these different metrics that help tell you performance, especially in imbalanced class situations like precision, recall, true positive rate, false positive rate. It's always good to break out the old confusion matrix. And I think just in general, make sure you understand the confusion matrix. Typically in interviews, like if a candidate is not able to know what precision is, that's usually a quick, like, okay, we can't advance. These are core fundamental concepts. And then even just knowing how does this help when something is imbalanced, right? And let me just quickly, yeah, someone mentioned data is highly skewed. Exactly. So again, let's say it's a binary label. 99 or 95% are zeros, 5% are ones. That means I can trivially get 95% accuracy by always predicting zero, because my prediction will be accurate 95% of the time. But you'll have horrible, for example, false negatives. So maybe anything else before we move on? Cool. Okay, hopefully that one was helpful. Another very core concept. I want to skip machine learning because there's a few more questions, but just in the interest of covering different concepts, let's do this slideshow. Okay, this we already covered. Okay, great. Next one, let's say statistics. And again, this will come up more in analytics type of interviews. This one, again, gold standard, but you can go really deep. And this could be, how would you describe hypothesis testing and p-values to a non-technical stakeholder? And then, okay, also let's add some twist. To a non-technical stakeholder and then to a technical member of your team. Give me your two flavors.
Yeah, again, this is a very classic question, Semi. I mean, by just talking about this question, we can easily assess if a person knows about A/B testing, distributions, I mean, central limit theorem. So it's a very classic sounding question, but it's an important one.
Exactly. And I'm actually finding these days with like the prevalence of AI, people used to just maybe ask one question and then move on. But now it's like ask a question and then ask a follow-up and then ask a follow-up and then ask a follow-up.
Yeah.
Because if you know it, you should be able to respond very quickly. But then, waiting for potentially like a ChatGPT to kind of explain it, or you're waiting for time. It just is an easy way to really sniff out how deep is your understanding in this concept. So again, some things you could approach, like what is a p-value? What is hypothesis testing? What do these terms even mean? You could try and frame it with an example, right? For example, a p-value of 4% would mean XYZ. Okay, seeing some good responses. Again, feel free to respond in the overall chat or just the hosts and panelists, fully up to you. Seeing some good terms, significance, null hypothesis. Awesome. Maybe we can jump into walking through it a bit. All right. So just visualizing it. Maybe we can share some explanations. Right, like what is the p-value? What is hypothesis testing? Generally, you have some hypothesis, right? Maybe through an A/B test, you're trying to evaluate if some change you've made to your website has an effect on some metric that you care about. Excuse me. And we use hypothesis testing to see if there's enough evidence to support or reject some claim, right? Maybe that changing the color of a button on our checkout page will materially and significantly impact conversion rate. So you can think of it, oops, I accidentally clicked up arrow. This is a nice visual understanding, right? On your distribution, we're really just trying to understand what is the probability of what you observed after you've run a given A/B test, a given hypothesis test. What is the probability of seeing the outcome that you saw, or more extreme, assuming the null hypothesis is true, which is saying that you always start with the hypothesis that there is no difference between, let's say, blue button, green button. And then you try to gather enough evidence to either reject this or fail to reject this. We can quickly just go through the chat. Yeah, good follow-up questions. Yeah, statistically significant. Everyone likes to use the 5% value. Yeah, which part of the explanation would change speaking with a technical stakeholder? I think once you're talking with the technical stakeholder, you can maybe bring up more statistical concepts like central limit theorem. You can bring up how maybe this relates to your sample size, even decisions for like criticality thresholds, right? You can talk about experiment power and maybe how p-value basically corresponds to something like probability of making a false positive, while 1 minus power corresponds to something like the probability of making a false negative, and how these things weigh against each other. That could be one way to take it.
Yeah, one thing, so you might see or read from some text, people having really strong opinions about how you describe hypothesis testing, what p-value means. For example, when you have a null hypothesis, uh, I mean, if p-value is, say, greater than 0.05, let's say this is a significance level, are you going to accept null hypothesis or are you going to fail to reject null hypothesis? What is the difference between these two things? So accepting the null hypothesis versus failing to reject the null hypothesis. Sometimes the interview may be getting deeper into using these terms, and then you may be confused. So make sure that you understand hypothesis testing, p-value, and read about it from different sources and try to understand what people mean with these words. Fail to reject versus accepting. Are you going to accept the null hypothesis or you're going to fail to reject the null hypothesis? So these are two these are two distinct things to say. Yeah.
Exactly. Perfect. Okay, so and yeah, we actually basically already covered this mostly in the previous question. Maybe one thing, because we have 15 minutes left, I would like to cover some other topics. So there is a chance to get probability-based questions. I think maybe we can just cover a straightforward one, which is like Bayesian probability. I mean, that's, again, super fundamental. You can go many different ways with it. I've gotten this in interviews where it's, okay, can you tell me if, actually, can you solve this Bayesian problem, right? And maybe you'll have some time to walk through the math, or at least talk through how you might think about it. A super common one is these disease type studies, right? Where you might be told 1 in 1,000 people have a particular disease. There's a test for it, which is correct 98% of the time. And the test also has a 1% error rate, right? If the person being tested does not have the disease. Then you ask the follow-up. So, given that someone tests positive, what is the probability they have the disease? I'll just say Bayesian, Bayes' theorem is super interesting. It's also very unintuitive. I think there was some great excerpts from a book. I think it's Thinking Fast and Slow by Daniel Kahneman. It's like a very well-known psychology book. Most people intuitively do not think in Bayesian terms. There was this fun example while people maybe write their answers in the chat or their approach of basically they were asked, okay, is this person that we're about to describe to you a farmer or a librarian? And then they give you the information that, okay, by the way, this person is a little bit nerdy, or they wear glasses. They like to read books, and a few more other like descriptions like that. And what they find is 90% of the time people will be like, yeah, that person's a librarian with very high confidence. But it's funny because no one ever seems to even recognize, because okay, maybe that person is a librarian, but and this is how it gets into Bayes. Well, how many librarians are there in the US? And this is for the US versus farmers. Because no matter what, if you have 100 times more farmers than librarians, you would assume with no information that this person is 100 times more likely to be a farmer than a librarian. And then, okay, maybe you update that prior because you've been given some descriptions that matches a librarian. But still, does it suddenly go from 1% chance to 99% chance? And most people don't even recognize that when they give the answer or when they describe why they thought this person is for sure a librarian. So TLDR, yeah, Bayes is super interesting how we kind of update our priors and most people don't think about it. So I'm seeing, okay, 1 out of 10 chance they have disease. One thing we can just do is walk through some of the examples, just being familiar with this equation is probably the core of what you have to know. Best thing to do is just highlight your knowns, right? You can start to frame this like, okay, let T equals the fact that this person tests positive, let D be representing the fact that this person has a disease, and you've been given some information. So you know the probability of D, of just anyone having a disease, is 1 in 1,000, right? That's given. You also know that the probability of testing positive, given that they have a disease, is 98%. That was also told to us. And we also know that the test has a 1% error rate, which means the probability of T, given that they don't have the disease. And I won't walk through too much of the math here, but you can actually compute the core part here. What is the probability of T, really, this thing that comes in the denominator? The core part is knowing what is the probability related to them testing positive and not having the disease. And someone said 1 in 10. I don't know if that was rounded, but it's close enough. So I'll give you credit for it here. It's about 8.93%. Just in the interest of time, I don't want to walk through the math, but it's here. Feel free to revisit it.
Just one short comment, Semi. A lot of times these kind of questions, remembering the mathematical equation, say Bayesian equation, would be the simple part of it. I think the most important part is how you can model this. So how you can say that let T be this and then let D be this. So that once you get that part right, I think the rest will follow.
Exactly. Yeah, that's really the framing, because then the rest is more plug and play. Sometimes they might just ask kind of on intuition, like that farmer example. I mean, what do you even consider? Are you considering what is the baseline probability of again, a person being A given B? And you can advance from there. Okay, there's a lot that can be talked about on Python, but I think, just showing code we'll need more time on this. Just know that live coding on the fly, is very, very common interview questions. It can either be related to Python or SQL. Wrong button. Yeah, it can be related to Python or SQL, and depending on the job, can go sufficiently deep or shallow. There are some examples here. I think really the biggest name of the game is just practice, 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 and refer to some of the resources that we shared earlier in the slides. They're great at structuring your practice. We can talk about pandas, typical data science, data structures, and algorithms. Lots of different SQL questions, but the reason I'm skipping ahead is because I want to go into problem solving. this is the ultimate, and this is actually the round I interview with, or I tend to do my interviews on. We give candidates a relatively vague premise, maybe related to ML if it's an ML position, maybe related to analytics and metrics if it's an analytics position. And we just want to see how you, as a candidate, structure your thinking, understand how to frame a given problem in a machine learning context, if it's, for example, machine learning, and then walk me through. Then, I might poke and prod and dig into certain questions as we go along to really make sure you understand the concepts that you're bringing forth. But let's say in this one, let's say you work at an e-commerce firm and you've been given a general problem statement that your company wants to reduce fraudulent transactions at the point of sale, right? So maybe we're seeing, okay, once people are making a transaction, they're buying something on our site, there's a bit too much fraud and it's costing us a lot of money. We need to reduce fraud. How should we approach this? And how should you, as the data scientist, approach this? Now, of course, you probably won't be able to answer this in a few sentences. So totally fair game. If the chat, it might be difficult to give you responses in the chat. But at the very least, maybe try to give like a framework of how you would move from A to Z in this problem, or even some clarifying questions. There's a lot of ambiguity packed into this statement. What do you need to know to sufficiently tackle it? And here I'm just sharing a bit of a pipeline, hypothetical pipeline of what this might look like, right? But even clarifying, like, do we have transaction data? Do we have labels, right? Is this a supervised problem where I have known fraud before? No worries. And yeah, if you want to send your clarifying questions, please do. It's always great to get different perspectives. Anyway, data prevalence, do you have the data you're looking for? What data would you even want to look for, right? Oftentimes, especially in a lot of organizations, nobody will just hand you a CSV. You have to be the one to understand what data you need, what is available, and what would help you in the problem. Even clarifying what is fraud. What defines a fraudulent transaction? Do we have a known label? Do we infer fraud? What does that look like? Then you can start talking about, okay, maybe now that we know we have the data, and you can say, yeah, this sounds like a binary classification type of approach. We're either predicting fraud or no fraud at the point of transaction. Then maybe we can talk about interesting features. This I'm trying to understand as the interviewer, your kind of domain expertise or intuition on the problem. Can you bring up good ideas, good features that would be reasonable to help predict this label? Maybe the person's amount of credit cards, maybe where the transaction is taking place relative to where they live. Bonus points for some features that represent historical information, like how many transactions have they had in the past n seconds or n minutes or n hours. Yep, seeing some great responses from Anisha. Okay, so there's the whole feature part of it and data part of it. Then we can go into modeling. And even before that, you might want to clarify, like, what is the company trying to optimize? They say reduce fraud. But again, there's a very trivial way to reduce fraud, which is to say every transaction is fraud, right? So how are they thinking, or is there any information about the cost, let's say, of a fraudulent transaction? Do we need to care about, hey, we don't want to bother customers too much by predicting fraud too often? Really, what we're trying to get at is there any understanding of some business number related to a false positive, predicting fraud when there wasn't, a false negative, letting a fraudulent transaction slip, anything like that? Because then we can tune our model accordingly and tune our metrics accordingly. Lastly, let's assume that that's not the case and we just want the best performing model, irrespective of business transactions or business values, right? You might get into metrics. This is clearly imbalanced. You recognize that it's imbalanced. Would you hopefully understand that accuracy is flawed and use metrics like precision and recall and F1 score? Bonus points, do you understand why precision and recall alone are not always good metrics? Because they're dependent on a threshold, which is often arbitrary. So a lot of the times, candidates might not even understand that the model does not naturally produce a 1 or 0. It produces a score from 0 to 1, continuous. And we arbitrarily choose a threshold. So there are metrics that are threshold agnostic, like area under a precision recall curve or receiver operator curve that help tell you metric or a model performance independent of a threshold selection. So this is where me as the interviewer, I like to kind of poke and prod into understanding. I might even ask, how can you make sure that this, let's say it's imbalanced algorithmically at the model level, right? How can you penalize making a mistake on the minority class more than making a mistake on the majority class? So really what I would try to get at is, do you actually understand the loss function of a classifier, right? Do you understand negative log likelihood or binary cross entropy? Same things. And then that really tells me like, okay, you're really familiar with the tools you're using. There's bonus points for setting up the training and validation and test framework. Anyway, as you can tell, we can go really deep here, which is why it takes an hour. Awesome. Cool. So I know that was a bit of a fire hose to wrap it up on, but I do like these problem-solving questions because you really get to understand the candidate's strengths and weaknesses, and you're not expected to know everything, but we can go many different directions. So that's, I guess, the core of what I wanted to share and what we wanted to share in this presentation. Hopefully it helped everyone feel a bit more prepared. I'd like to share this one. Right, hopefully it makes you feel a bit more prepared. Hopefully it helps out. And yeah, feel free to follow along, follow with Magnimind, ask any clarifying questions in the chat. Yeah.
Okay, so Semi, I think we are almost out of time, right?
Yes, yeah, that's I think we're at time now.
Yeah.
Cool.
Yeah.
Yeah, so I guess we can just wrap it up from here.
Yeah.
Awesome. I know people are asking for the slides. Maybe there's a way to share those. I'm personally not sure. I think we can follow up with the Magnimind staff here as well. Again, it's being broadcast to YouTube and I believe LinkedIn as well. So you'll be able to find all the content again. Thank you everyone for attending. Hope it helped and see everyone later.
Thank you, everyone. Thanks, Semi.
Thank you, Dr. Duran. Thank you, everybody.